All right, we've looked at the reciprocals, what secant and cosecant. Now let's look at the ratios, the tangent and the cotangent. And the reason why I call them a ratio is because it is a ratio of maybe sine over cosine or cosine over sine. So let's look at the one that you've heard the most of, which is tangent of theta. We know tangent of theta in terms of the unit circle is y over x. This is a ratio. This is why I call this a ratio function or a ratio trig function. Wow, can't talk today. All right, so what we're going to do here is I'm going to graph this for you. But before we do this, let's talk about some key features. Let's talk about the domain. The domain of tangent is basically going to be all my x's except when x equals 0, because we can't have 0 in the bottom part of the fraction. Except this is an angle. So this really is the same thing as sine of theta over cosine of theta. So everywhere cosine 0 on the unit circle, I have to take out of my domain. So it's going to be the set of all x's such that x is an element of the real numbers and x cannot equal, well, when cosine equals 0. Well, that starts at 0. Nope, that starts at pi over 2. Wow. Pi over 2 plus pi k when k is an element of my integers. All right, it's the same domain as secant. All right, my range, though, is going to change. My range of tangent is all real numbers. Amplitude. This doesn't exist because this does not have a max or a min, so this does not exist. Here is the big difference, my period. My period of sine and cosine is 2 pi. Period for these ratios is going to be pi. And that just makes sense because tangent represents slope of a line. It's going to give us the slope of the terminal side of our angle in standard position. And slope repeats every 180 degrees. A straight angle is 180 degrees, which is just in terms of radians is pi. So my period for tangent and cotangent are both going to be pi. All right, so let's look and see what the graph of tangent actually looks like. So I'm going to graph, let's see, pi over 2, pi, 3 pi over 2, 2 pi. Let's do negative pi over 2, negative pi. All right. Everywhere where cosine is 0 is going to be in a vertical asymptote. Cosine is 0 on your y-axis. And then from here, it's going to look like a cubic function sandwiched between my asymptotes. So ladies and gentlemen, that is the graph of tangent. It keeps going on forever and ever and ever. So that's the graph of tangent. So let's look to see how to do a transformation on tangent, because it's slightly different just because of this period part of the points we're going to pick, but the process is going to still be the same. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.